So we are going to discuss a very important topic today in Sorosha classes, which is Bend's rule, and the topic is very important for competitive exams like CSR, JAM, and DRDO, okay, or the CUCT exam. The most electronegative group or atom prefer to bind with the orbital that has less s character, and electropositive group or atom will prefer to bind with orbital having more s character. Okay, so less s character. So this is more s character, and somewhere it is less s character. Okay. So this is basically applicable for trigonal bipyramidal structures and the pentagonal bipyramidal structure. Okay. So we will write in another way in trigonal bipyramidal, the more electronegative groups prefer the axial position, and vice versa we will say more electropositive groups prefer equatorial position. Why so? Because in a trigonal bipyramidal structure, which is I am showing over here with the orbitals. Okay, so if you write the orbitals, we will say in a trigonal bipyramidal structure, basically it is a sp3d, okay, hybridization. So over here we have three such lobes which are formed due to the combination of remember s plus px plus py orbitals, and the angles between them is perfectly 120, and there is another lobe which is formed by the combination of pz and dz square, okay, and these are called the axial lobes, okay, and these are called the equatorial lobes. So in other words, the equatorial lobes has more s character and the axial lobes has less s character. That is what we can say. Again, the angle between the equatorial and the axial lobe is going to be 90. Okay, so one can say more the angle between the lobes, more is the s character. Okay, that is what one can say. So let's solve one molecule. Say if you are given simply PCl5 in the gaseous state, then we know that for phosphorus, the total phosphorus pentachloride, if we do the total valence electron count, we will say what? Okay, it will be 5 plus 7 into 5, that is all total 40, which is if divided by 8, because the number is more than 8, we get 5 electron pairs. So hybridization obviously is sp3d. There's no doubt about that. So it will be having the structure as follows, in which we will place the phosphorus in between, and we have these bonds having more S character, and there will be this axial bond. So the chlorine will occupy these positions, and there is no confusion over here. But what if you are given systems in which there is a mixture of two different electronegative atoms? In those cases, what one can do? So let's take an example, say PF2Cl3. We know fluorine is more electronegative than chlorine over here. Hybridization, again, it is sp3d, there's no doubt about that. So over here, if we think about placement of the atoms, chlorine being less electronegative will be occupying orbitals having more s character. So it will go in the equatorial plane, okay, something like that. And the fluorine will be placed in the axial bonds, which is having less s character. Okay, so that way, if we think this is the equatorial plane, okay. Now out here, one should remember more the okay. So this is what it is. Again, if you are given another molecule in which, say, it is PF3Cl2, then again we will say it will be having hybridization sp3d. So now if you have to place the atoms accordingly, we will say the chlorine will be placed in the equatorial bonds, and fluorine also, one fluorine will be placed in the equatorial bond, and the other two fluorine will be placed in the axial bond. And if you have to watch the equatorial plane, we will say this is my equatorial plane, okay, somewhere here. So let's rewrite the chlorine atoms properly, just to make the structure more beautiful. And here is the equatorial plane. Now, if anyone was to ask you about the dipole moment of this molecule, considering that the molecule is not undergoing any pseudo rotation, okay, or has no fluxionality, that means the positions are fixed, okay, the positions of the atoms are fixed, that is, the molecule is non-functional. Okay, these type of questions, obviously they come in the CSR and NET. So having considered that, then one will say, if the molecules are considered non-functional, then obviously this molecule will be having a dipole moment 0, because the bond moment of fluorine are cancelled by the fluorine on the opposite side, whereas the bond moment of this PCl will be cancelled by the resultant PCl of these two bonds, okay. So this will be 0, whereas over here, if we consider, no doubt this fluorine will cancel out the bond moment of that fluorine, but the resultant moment of the two Cl bond moments, which is lying at an angle of 120. So this is mu resultant PCl basically. Here also we should write mu resultant PCl, and this is only mu PCl. Okay, so this one is cancelled by this one, But out here, this is not equal to mu mu pf. So these two things are not equal, and hence this particular molecule will be showing the dipole moment. So that has to be kept in mind. Okay. Now